There we go. So, okay. Was the math section from 73 as well? Do you know? Oh, sorry. Yeah. Okay. 72F. Right. Okay. Where am I looking? Okay. Still some of those later questions, right? Any of the earlier ones that you were like, wait, I thought I got this, and yeah. Okay. Okay. So let me just grab 15. If you want to maybe just even tell me the ones that you did get wrong in that sort of earlier group, I can scan around. Yeah. 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 Okay. Okay. So a lot of that towards the end, right? Okay. And even when we get into the 30 range, it's like a little more difficult, right? Um, okay. So let's just grab a few of those. Start there. So I'm not sharing yet, am I? There we go. Okay. So what's your methodology here? Remember, what does the absolute value do? Yeah. It kind of makes whatever's inside positive. Okay. So first, let's solve what's inside. What is inside? Oh, okay, wait. The absolute value doesn't meddle with the signs, like it's a sort of it's a function, right? Functions take one thing and give you another, right? So the one thing that they're taking, it doesn't kind of like affect the other. What you would be doing would be distributing that in some way to affect it only on the -6 and the 7. First, we have to do that. Remember, there's a bracket here. This also counts as a bracket. And so we can only give it one thing. First, we have to solve that one thing there, that red bracket, and then we can take or ignore the sign of that thing, right? So it will -42 plus 32. Which, good. Yeah, wait, -10 or +10? Yeah, right. The answer inside is -10, but then we take the absolute value of it, right? So that you will only take the absolute value. Like you can't really distribute the absolute value. Most, squareds, like you're sort of used to, this is the most dangerous one, right? This distribution here, because then you're tempted to do it here, right? Which you can't do, right? But you've maybe accidentally done that one, right? But you can distribute like some other things too, right? Like even a constant out front, right? This you can distribute, right? Absolute value, like those are all functions. Absolute value, you will never be able to distribute. So you always have to sort of like just give it the one thing, one number that's there, and you have to sort of like work from that point, if that makes sense also. Sometimes you'll also have a variable in there, right? So we'll be able to say when the inside is negative or when the inside is positive, depending on the x value, right? Okay. But yeah, like that's sort of like, I think more helpful for some more complex ones, right? Okay, so let's look at this one. So factors of polynomials. This is your advanced function stuff, right? Didn't you start with polynomials? This is a cubic, right? But it's not even that hard of a cubic because it's one that we could have given you in grade 10. So you got this, obviously x out front, and what was the other one? Wait a second. 2 and 2x minus 3. Sorry, you lost me. Yeah. Um, how did you factor this? Yeah. Ah, sorry, I didn't hear that one. 2x minus 3. Right? Is that right? No, plus. Right? You said you got 2x minus 3 out of it? What was the other factor you got? You got x minus 3 and I heard like a double bracket there. Something like that. Can you show me? Can you just show me? That's okay. Oh, okay. You're saying sort of along the way. Okay. But then eventually you get this, right? Sorry. I thought you were giving me this one. Sorry. Okay. So, yeah, good. That works out. X is not a factor. Didn't you start with that? Right? Remember, what you have left is a quadratic. You started with a cubic. You got to keep it a cubic. Right? So you got to this, and then that you turned into this, right? But that x was still out front the whole time, right? So any of the others that you got? No. So just f, right? Okay, sorry. Okay, so let's jump to this one. Okay, so we get some sort of extra pay, 1.5. How much for a week? Which earns 47. Okay, so this is kind of like a piecewise type function, right? For all everything under this value, do this, and for everything over this value, do that, right? Okay, so how do you do this? Y 10 times 4? Yeah, 10 times 40, so 400 times the pay, right? Yeah. Oh, okay, okay. What'd you get? Okay, yeah, yeah. So something's up, right? Like if I was going to get $400, like that's part of that zooming in, zooming out. Like when if you do have a second, sounds like your speed is pretty good here. The zoom out is like, does this make sense? What's the best thing I could do? If I got paid $400 for 40 hours and you gave me $410 for 47 hours, right? Like that right there is a signifier, right? So that's you were in the zone and you just kind of moved on, right? But zooming out, you can say something's wrong, right? And catch that, right? And that's sort of sometimes the difference. That's like the subtlety between like 85 and 95%, right? Like catching those little silly mistakes, really, right? Because it's not like you didn't know to do that. Okay. Can you give me a couple others here? Okay. Three. Yeah. Okay, so this one is about this, which I can grab. Did you have any trouble with any of the others, 35 to 38? Was it just the 38th one there? Okay. Um, okay. So then let's go from there. So we'll start with 39 here. Oh, way over there. Okay. Okay, so like we take this for granted, right? This should really have a 2 out front because it undoes this, right? So what do you think this undoes? Yeah. So anytime we put a number there, it kind of indicates, and remember that these are actually, when you rewrite them, that's actually to the power of 1/2 because it undoes it, right? When we multiply them, we get, I mean, if this was an x, right? We get the something to the power of 1, right? And so here, to get to something to the power of 1, this would be 1/3, right? So same story. Whatever this number is really the, denominator of this fraction. It's a 1 over. Okay. Okay, so then how did you sort of start to solve here? Oh, we could do it faster. Okay, so, right, like 10, let's take 10 away from both sides, right? We can just solve. Start to solve. So we have 3. How do we undo a cubed rooting? We, yeah. But wait, how do we undo it? Which is what? You cube it, right? Remember, they are designed to undo each other, right? So we're going to cube this thing, which means we also have to cube this thing. And then we just get plain old 3x minus 9 is equal to 3 cubed, 27. Add 9 to both sides, and we can maybe stop here, right? We get 36, and now x is, yeah, right. Okay. So, um, yeah, whenever you have, like, knowing that this is a solvable equation is really the sort of like big step here. How do you know? How do you know equations are solvable? So you should be able to tell me when this one, or even let's just do it simply, to involve two variables, Yeah, right? But if I tell you that this, well, this I haven't hidden the number of basketballs I tell you. If I tell you the number of basketballs I have minus 2 is 5, but I haven't told you the number of basketballs I have, right? Well, you can just solve for that. So this one is like, no, it's impossible. I can always trick you, right? So same thing. Here, one equation, one unknown. It's solvable. Let's just attack it. Yeah. Like there will never be really anything that you can't undo unless it's like a trig function. It will be really kind of tough or tricky, really. You just probably are going to use one of your nice triangles, right? One of your 3, 4, 5 triangles or one of that. But otherwise, one equation, one unknown, it's just undoing all my old friends. Multiply by 2, division, square root, all that stuff. Okay, so suppose ABCD is a standard XY coordinate plane such that BC is on the x-axis. The midpoint of BC is the origin. Okay, so let's kind of like draw this thing that they're describing here. Like that, right? Okay. A has positive coordinates. Yeah, sure. Um, what is that number there? And one coordinate unit is equal to 1 meter. So like one of these cubes, I'm assuming, or one of these squares. So what is the coordinates of D? Wait, what do you mean by 90 degrees? Oh yeah, sorry. Was this the one that you circled with? Or you got wrong? Or, okay, so let's just take a second here. Point M starts at A and is rotated counterclockwise about P, a total of 450. Okay, so I'm going to ignore the first 360 of that because that's just going to return me to where I am, right? So then that's an extra 90, and it's counterclockwise, so it's this way, right? So I should go here, right? Like my shape should rotate by 90, and my shape I think is equilateral, kind of, right? Okay. M is at the same location as which of the following points? D, right? Yeah. Okay. So then 38. So I drew the sort of like coordinate system that they describe in the first sentence. And it says A has positive coordinates and one coordinate unit is equal to 1 meter. Is that going to be helpful here? No. That's a distraction, right? That's a smoke screen. What are the coordinates of D? There's no meters featured in any of the answers or anything. It doesn't matter. So what are the coordinates of D? Okay. Well, I drew the thing there, right? So you should be able to sort of tell me what D's coordinates are. Yeah, J. Yeah. Okay. This is actually one I've seen on multiple tests before. Not likely to like see it again, like generally when you see kind of like one question that has for the next 4 questions, this is the thing that matters. You won't see one exactly like that again, but I have seen two that are similar to this. Okay. I think it was like P was like somewhere, P was like on the left or something, but it was very similar. Okay. Um, so there was another one here, 33. Circumference of a third circle is 20 centimeters. What is the length centimeters of the radius of the circle? Oh, okay. So, what'd you do? Okay, what's the circumference of a circle? Good. Oh, did you write it down? Oh, okay. So that means we got to do that check, right? Of what we talked about, right? Is the exponent on the formula matching what I'm looking for, right? So that means that, we all have our common mistakes. Like for me, you know, inequalities, right? Like I still have to picture, like the alligator eating the bigger number, right? Like I can do like, sort of algebra with these inequalities, but I still have to think about it in a silly way. But because I know I kind of am bad at it, I don't really make the mistake because I have that sort of like adjustment, right? So that's like, it's on my radar. That little that little equation thing, because I think that's sort of the second time maybe where we've had the circumference thing, right? Or we've kind of like, played with it. So, okay, we just have to add a little check there, right? And that's the thing, the R value, right? Or the exponent on it. Okay, so then obviously I don't think this is that challenging, right? I don't think we need to do this. Well, equals. Yeah, yeah. Let's do it. Yeah. Oh, okay. Okay. So, cos of L is 7 over 16. What is the sine of N? Okay, so this is close to the one that I think we've seen before, right? Where they don't ask us exactly ever about the angle. They ask us about the trig of an angle, right? So we can get away with just using the ratios. This may not be the true side lengths, but I'm going to use these values as if they are cos, which is ka, so this would be adjacent to L, 7, and then hypotenuse 16, right? Which means now I can kind of solve for this, right? Which I'm imagining is 207. I don't even have to do the math on it. That's another beautiful thing, right? Um, I mean, I might get burned by that, but like this is pretty, I'm pretty safe in that, right? Like I don't think this matches up to anything nice, right? Because 7 is prime, 9 is prime, yeah. What is the sine of n? Okay, so now, okay, so did you draw on it? Ooh, yeah. Oh, okay. Ooh, okay. I see. So you did 7 over square root of 207. Yeah, yeah. And remember, the cos of my angle, like if we are the two opposite angles in a right angle triangle, the two that matter, obviously not the 90, the cos of my angle is the sine of your angle. Like look, the answer is 7 over 16, right? So the cos of my angle from my side is my adjacent, which is your opposite, right? So the cos of my angle is the sine of your, and obviously your cos is my sine, right? So that's something you could use here too, right? Another even faster way to do this. Okay, but drawing that like not even hard, right? You know, it doesn't even have to be a nice triangle. You can give me one of these, right? And it's like worth it to do it on the page just to see it. Okay. Okay. Let's keep going. What else we got? 50 or were anything in the 40s here? Okay. Okay. And so what was the sort of like mental fatigue level like going into it, but also like getting towards this level of the test? Okay. No, I mean, and it's like it's worthwhile sort of data to have regardless, right? Like, and it's good. It's like honorable that you're putting in time regardless, right? So, and that will like pay off. So, um, there's no reason to like be upset with that or anything, right? Okay, so 44. Lynn has, okay, sure. Yeah, I know. And that's what they're designed to do. They're designed to be wordy. The math is like usually addition or something, but they're designed to be wordy. Notices that there are 5 more dimes than quarters, 1 more nickel than quarters, 25 more pennies than quarters. Okay, so I'm hearing an x equals quarters, x equals number of quarters. How many pennies? Okay, so all we can, like ignore the first part and just say this, right? But then she has this much, right? Okay, so let's just kind of say start with x is the number of quarters, right? And it's probably been a while since you've done one of these questions, so you'll recognize it, right? But the count versus the value are going to be our two equations, right? So we know that the total value is 3.67, right? So let's kind of call, you know, for a short time here, let's call y the number of pennies. Let's call z the number of dimes. And let's call w the number of nickels. Okay? And really, they talk to us all in terms of x, right? So let's kind of like solve for the equation of each of these. So how do we find the number of pennies? If I have the number of quarters, let's say I have x. Yeah, good. What else? Okay, so now the total value is going to come from each coin's value, right? Wait, does she have um, a certain? No, she doesn't have. We're not told how many she has. So let's just kind of like use the total value here. It's going to come from what? Good. But remember, this is the number of each of those. So what do I have to do with the value for the number of dimes? Yeah, but each one of them is different, right? So dimes will be this, and then that's by dime, so that's x plus 5. And then to that, we add, you do the next one. Yes. X plus 25. Yeah, good, right? Like we need to do that, right? Good. And then anything else? Was that included in the value of the 365? 367? Yeah, it is. So we should add it. And what's its value out front? And what's its number? Just x. Just x. All right. So now we have a big old nasty equation for x, and we can just solve. Right? So yeah, this is sort of like the value, and like you can do this by also using this on a multiplier to this, right? And taking it away from our total. Because you'll end up with 0. That and then a 50 cents, right, of dime. So let's take that away, right? And then, right, you with me? So you can kind of do it that way too, and you can do it faster that way. But generally, this is the sort of system, and you'll see a few like this. Okay. Okay. So what did you get here? Yeah. 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 So I would look to the I would look to probably, yeah, I guess it's tough, right? Because quarters could jump in there too. But I would look to the nickels. One more nickel than quarters. So yeah, I guess it kind of all jumps back to how many quarters you ask. You can't really do any trickery with like that. Besides, like there has to be at least two pennies somewhere, right? So 7, 12, 32 are the only valuable ones, right? Okay, consider the transformation of the standard maps each point to the x, sure, for a certain positive constant. So are you understanding what they're describing that first sentence with lots of words, but they're basically saying they're going to stretch it. Right? In particular, this transformation maps this to this. Okay, so they've kind of given us a okay. So they gave me a 3 comma 9. We have to find the k value, but it's on to 3 comma 9. It becomes what? Oh, sorry, 1 and 3. So it's 1/3. So k is 1/3. So then apply that to this, right? Yeah. Oh, yeah, yeah, right. Yeah, but it's a k, right? It's a multiplier. Yeah. Okay. So yeah, I mean, this sounds like one of those ones where it's like you got to get burned before you know that it's, to be aware of it and you're going to remember it from your scar, right? You're going to recognize this type of question if you see it again. I don't think you're going to get this one wrong again. Okay, and that's what we're doing. Part of this is just exposure. So matrix multiplication is kind of like the dot product of two matrices instead of the dot product of two vectors. The dot product is for vectors, but the matrix multiplication is for matrices. But it's the matrix version of it. Okay. Okay, so this is the kind of like general idea here for any sort of 2v2, and if they don't exist, like if it's just E and G on the right one for us, right? Then the F and H terms don't exist, so that's those ones there. So it's just going to be one of these vertical ones. So you'll only ever get, I think, 2v2 multiplication, okay? There is matrix multiplication that doesn't work. That doesn't make sense. That's not allowed. Where the amount that I'm lining up with the vertical amount doesn't work. So say, for example, I try to do this. And multiply it by this. I can't do it because it's asking me to take these three things and line them up like this, but what does this line up with? Right? So that's the problem. You can have matrix multiplication that isn't like possible or allowed. Okay. Okay. So Um, that's sometimes the answer. If the question seems really hard, that might be the answer too. Okay. Okay, so 52, 54, you said as well. Let me just grab, okay. And something else that's worthwhile that we have the advantage of is to look at where you are getting your, because I'm seeing a lot of these like in the standard plane type questions, right? Which might mean some focusing on those types of questions, which means going to the test, seeing which types of questions those are, and just doing those questions, and then moving on to the next test and doing it, right? And then come back to that test like 2 weeks later, and you can probably do most of those questions again and forget about it. Okay. Okay, what are the real values of m, if any, such that any line through the point, whatever, will be vertical when graphed? Okay, so it needs to be a vertical line. Okay, what is true of vertical lines? Mhm. So keep the x constant and tell me what m can be. Why can't it be 7? Mmm. Okay. Ooh, I like that. So, yeah, I'm with you on that. So is the answer J? Yeah. Right. And it would need to be a line. Uh, no, 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 that's it. Okay. So that kind of came to you where, like, did that just was a little too confusing or too wordy at the time? What did you feel in the moment? Okay. Okay. Yeah, because it was like you were confident in it just now, right? Um, okay. Yeah. Sometimes that is like, the sort of mental fatigue level of these questions as well. And it might be worth it even to kind of like take a peek at some of these too, like at the start and try some of them and then kind of like get back warmed up, come back to them or something like that, right? Might be worth evaluating your strategy. Okay, so sure, which of the following is not true? Okay, okay, okay. Yeah, so now with the time to evaluate it, tell me, like, do you know what the true answer is? Yeah, okay. So let's kind of like provide proof then. This is one of those ones where we can at least like think through it, provide proof for all the others. So why is F true? Mm, so what I'm saying is f of x doesn't change when I take the absolute value of it, right? Do you agree? Why doesn't it change when I take the absolute value of it? Some numbers do change. Why doesn't f of x fall in that category? What types of numbers change when you take the absolute value of them? Sometimes you take the absolute value, it doesn't do anything. What type of numbers am I talking about? Positive numbers, right? Like absolute value, all it cares about is this thing positive or not? If it's positive, it just leaves it alone. So the absolute value of a positive is just the same thing, right? The absolute value of a negative is when it gets changed. So if I'm telling you that f of x doesn't ever get changed when I take the absolute value of it, I'm in a way I'm telling you it's always unchanged by the absolute value, which means it's always positive. Is that true? That it's always positive? The value of f of x? Why? Why? More easier than that. Look at your graph. It's above the x-axis. It's above the x-axis. All of its values are positive. Is that true of g? No. Sometimes when I take the absolute value of g, it doesn't do anything on the right side there. But when I take the absolute value of the left side there, it changes, right? Okay, so then f of 3, sure, yeah, they're equal to each other. That's where they touch, right? F of 3.5 is equal to 3.5. Okay, that's kind of hard to tell, but I guess those are two numbers that you would plug in and try, right? And then f of g of 1 is equal to 6. What is this? F of g of 1 is equal to 6 is the claim. Okay. Yeah. When I plug in 1 into g, you mean? Okay, so then that's really the same as f as 1 if g of 1 is 1. And is f of 1 equal to 6? Yeah, so that's good. Right. Okay, yeah, so you've seen this kind of notation before. Just wanted to kind of like check that. Okay, it's not so scary, right? You just kind of like do it first and then plug it in. Okay. Uh, so, so you said some of the later ones, 58, 59, 60. Okay, so I think we've looked at one similar to this before, right? With the parallelograms? Is that right? Okay. Okay, so now you have time. Let's kind of like, without time pressure and without, being too stressed about it, let's see if we can reevaluate. So I'll give you a second, and even if you do know the answer, let's sort of like make sure we know how we're getting there. Okay? I'll just give you a minute, see if you can feel comfortable getting there yourself. Okay. So let's um, let's sort of start by sort of saying this midpoint stuff. Are you comfortable that we're going to get kind of like the same kind of trapezoid, like in terms of angle, but just a little bit longer side there. All right? Is that fair? Okay. So where this one's 12 and this one's 25, right? And then there's even a bigger one than this. Let's just maybe do this. There's an even bigger one that is kind of like twice in some way. Okay. So this is actually an easier one first, an easier stepping stone before getting to here. Okay. So how much grew on each side here from 12 to 25? Like total of each side. We don't know which one got which, but 13. Okay. So then going twice the distance, we should gain, yeah, because we're going to gain another one of those. Comfortable with that? Okay. So now we know that the total down here is what? Another 13 on top of this, right? So 38. And now we just have to find a number right in between 25 and 38. Yeah. Yeah. So a lot of this is like smoke and mirrors, right? So and remember, like designed to be less than a minute. And then that includes like a 15-second, let me check if this is right. Let me make sense of this. Let me zoom out. No, not 20 minutes. No, no, no. Like the most I've ever like seen somebody consistently finish is like 3 to 4 minutes, which is like pretty fast. Pretty fast. I know, eh? Yeah, especially when you're like, wow, could have used this like extra half hour I just like it just destroyed this test on. Yeah, it's true. And it really only comes into account on the math test, like and science too, but it doesn't seem like for you, which is good, but yeah. And like I said, like the math section, the math is a problem or the time is a problem, but you do get a lot and you borrow a lot from those first 45 to use on these ones, right? Okay. So it's randomly selected from those, so we got a 1 in 5 kind of chance here. That B will be randomly selected from, okay, 1 in 4. That A times B is bigger than 0. Has to be bigger than 0. Okay, so talk to me. Good? No, no, no. Yeah, it's not 7. It's not, that's not how we do it. So, like, what multiplies to become bigger than 0 between two numbers? The numbers either, can they be both positive? Can one be positive, one be negative? If one's going to be negative, they both be negative, right? Okay, so either it's -2 and it's 3 possibilities with the other one, right? Or it's -1 and it's 3 possibilities with the other one, right? So are you comfortable with kind of like that, where those are coming from? -3, -2, -1, right? So that's a total of 6, right? Okay. And then, so those are the negative ones. What about where uh, where it's positive? Yeah, good. Yeah, I really should do a tree like this, right? Like another option might be, I might look to do a complement type question where it's sort of like a 1 minus, right? Like if I say, what's the probability that everything, you know, that nobody has duplicates of X, then I'm going to say, I'm going to look at the one that doesn't have any duplicates, right? And do 100% minus that value. And I'm going to figure out all the ones that don't have duplicates, right? or do have duplicates. Sorry, that's a backwards thing. The complement stuff, if you get to the data management, kind of makes sense. I explained that poorly, but this is kind of called a tree. So the options aren't too crazy, but yeah. And then the total is what? Why? Yeah, 5 options, 4 options, right? Okay. Oh, word salad. Distinct points A, B, C are collinear. What does that mean? They're on this. Yeah, they're collinear. Yeah. And B is between A and C. Okay. For D to be between A and C. Okay, so now that you know they're on the same line, do you want to try this one? If B is between A and C, then A plus B. Yeah, okay. So, yeah, there's no requirement for those things to be equal, just for sort of for sums to be true, to be sort of like equal certain things, right? So that could be 9 and 1, 7 and 3. They don't have to be equal to each other, right? Okay. Uh, B is between D and C. Okay. Well, let's kind of leave that for a second. Let's say why 4 isn't true. D is between B and C. So look at the statement that they give you, right? Look at the sort of steps that they take. They say start at A and then go to D, but then right from D go to B, and then right from B go to C. So this is AD, this is DB, this is BC, right? And so we actually have gone A to C. So where was D and B in that arrangement? Yeah, right. So that was the statement that they gave us. Okay. Um, okay. So yeah, I think like maybe I can here. I'm gonna send you a couple extra because you have now I think one extra, right?